Hello and very good evening to all the viewers. So today we're going to explain about instrumentation and measurement subjects. So my name is Muhammad Amirul bin Zulkifli, and there's others presenter names Muhammad Syazwan bin Hassan and Muhammad Arif bin Zainudin. So today we're going to present about application of measurement device. So what we're going to explain is a speedometer. So what is speedometer? Speedometer is a gauge that measures and displays the instantaneous speed of vehicles. So the speedometer have been invented in early 1888 by Gaussian Joseph Belusic. And for your information, speedometer for other vehicles have specific names. So example, boat, we call it peak lock. And another example is aircraft, we call it airspeed indicator. So the objective of our presentation is to determine the function of speedometer, to analyze error in speedometer, and to determine the causes of error in speedometer. As you can see that we're going to present about the application of bicycle speedometer. As you can see in the slide, there's two types of speedometer at a bicycle. One is digital speedometer and the one is analog speedometer. So next I'm going to call my our next presenter, Muhammad Arif bin Zainudin.
Okay, for the second part, I will present to you about the operation of the speedometer. Okay, this is the basic structure of the speedometer. Okay, first we got the drive shaft, speedometer cables, magnets, speed cup, hairspring, dials, and pointer. Okay, let's move to the next page. Okay, for the first step of the operation of the speedometer, firstly, when the engine turns over, the drive shaft turns to make the wheels spin around. So this is the drive shaft. It will rotate, and then the speedometer cables powered by the drive shaft turns as well. So when the drive shaft turns, so the speedometer cables will also turns. Okay, next. Okay, for the third part, the cables spin a magnet around at the same speed inside the speed cup. The magnet rotates continually in the same direction. In this case, it is counterclockwise. So when the cables spin the magnets, the magnet will spin at the same speed with the speedometer cables. Okay, fourthly, the speedometer magnet creates an eddy current in the speed cup. Okay, when the magnet turns fast, there will be an eddy current that will result in the rotation of magnets. So then the eddy currents will make the speed cup rotates in counterclockwise, the opposite direction of the rotation of the magnets, and as well as in attempt to catch up with the magnet. Okay, remember that this speed cup is not joined together with the magnet, so there will be an air gap between the speed cup and the magnet. For the and then for the sixth part, the hair spring tightens and restraining the speed cup so that it can turn only a little away. So if the hairspring is not included, so the speedometer will turn until it will close the dial. So we need the hairspring to limit the turns of the pointer. Okay, and then as the speed cup turns, it turns the pointer up to the dial, indicating the car speed. Okay, this is the summary of the operation of speedometer. The faster the car goes, the faster the cable will turn, and the quicker the magnets will spin. The bigger the eddy currents that the magnet generates, the greater the force on the speed cup, and lastly, the more it's able to pull up the pointer to the dial. Okay, so we will move on to the next phase by Syazwan bin Hassan.
Well, I am Syazwan bin Hassan, the third presenter. So I'm going to explain about the error in bicycle speedometer. First of all, I'm going to I want to tell you about the causes of error in the bicycle speedometer. Most of speedometer have tolerance of some plus minus 10%, mainly due to variation of the tire diameter. The tire diameter variation are where temperature, pressure, vehicle load, and nominal the tire size. Next, we're going to move to the calculation side, which is how we calculate the percentage error. Percentage error, as we can see in the slide, which is 100 times with 1 minus new diameter over standard diameter. How we calculate the diameter in millimeter is 2 times t times area over 100 plus width times with 25.4. Diameter in inches, t times a over 1/270 plus with w. Next, this is an example how we calculate the error. The standard tire error is 185/700 R14 with diameter 2 times with 185/70 over 700 plus 14 times with 25.4 is equal to 614.6 millimeter, which is equivalent to 24.220 inches. Next is after calculate this type, you can get the 57.6 millimeter, which is equivalent to 22.68 inches. Replacing the first tire and the wheel with the second on 50 inches is equivalent to 381 millimeter wheels. And speedometer reads 100 times with 1 minus 576 over 614.6. This is equal to 100 times with 1 minus 22.68 over 24.2 is equivalent to 6.28% higher than the actual speed. An actual speed of 100 kmh is kilometer per hour, or we can convert it to the mile per hour, is 60 mph. The speedometer will indicate 100 times with 1.0628 is equivalent to 106.28 km per hour, which is equivalent to 63.77 miles per hour. In the case of where a new 185 over 60 R14 tire of 620 mm, which is equivalent to 24.4 inches diameter, will have something like 8 mm tread depth. At legal limit, this reduced to 1.6 mm. This difference between the difference being is 12.8 mm in diameter of 0.5 inches, which is 2% in 602 mm, which is equivalent to 24.4 inches. Okay, we done the calculation, and then as the conclusion, at the end of the presentation, we can know the what? First, we can know the function of speedometer, and also we can know the operation of speedometer, and also we can know error in how to calculate the error in speedometer and the causes of error in speedometer. Thank you.